So finally, we're putting everything together to look at solving applications that are modeled by polynomial equations. We'll start with a strictly numerical application. We're told that the product of two consecutive odd integers is 255, and we're asked to find the integers. So what is it we're looking for? We're looking for two consecutive odd integers, and the product is 255. So you can assign any variable to equal one of the integers, but I'll use n. Let's say n equals the first integer. And every other number is odd. Every other number is even, every other number is odd, so we know that 2 more is the second integer. And you could just as well assign n minus 2 to equal the first integer and then n to be the second integer. Either one of those would work because we're just looking at if one integer is odd, 2 away from it is also odd. And then we know that the product of the two consecutive integers, odd integers, is 255. So that gives us the equation product n, or we could write this out as first integer times the second integer, second odd integer, equals 255. We've defined it as n and n plus 2, so n times n plus 2 equals 255. And now we've got the same problem, same type of problem that we've been looking at this entire section. We'll multiply through and then subtract the 255 to put it in standard form. So this is n squared plus 2n, and subtract the 255 minus 255 equals 0. And now we want to know, what will this factor to? N squared plus 2n minus 255. So since we have a leading coefficient of 1, we're wanting to know what two numbers multiply to negative 255 but add to 2n. Well, if we look at the factors of 255, if you write out the factorization of 255, we'll see that 17 and 15 multiply to 255. Now, since we're adding 2n, we know that bigger of the two, because we're adding 2n, is going to be the plus. So n plus 17 times n minus 15. And that would give us n squared plus 17n minus 15n, which is 2n, minus 255. So this means that n equals 17, or excuse me, n equals negative 17, or n equals 15. And that's simply from n, using the zero product property, we have n plus 17 equals 0, or n minus 15 equals 0. So now we have two possible values for our consecutive odd integers. If the first integer is negative 17, so if n equals negative 17, well then n plus 2 equals negative 15. If n equals 15, then n plus 2 equals 17. So the two possible combinations are negative 17 and negative 15, or 15 and 17. And these are both sets of consecutive odd integers, negative 17 and negative 15, and 15 and 17. So what we need to know is their product 255? Well, negative 17 times negative 15 is 255, and 15 times 17 is 255. So the consecutive integers, if we write this out in a complete sentence, the consecutive odd integers are 17, well, negative 17 and negative 15, or 15 and 17.